Motion number 2 is from the 2015 exam. It was a no calculator question. Mean score is 4.43, which is actually pretty high. In this question, it's a nice blend of motion along with some table ideas as well. We have Joanna jogging along a straight path, and her velocity is given in this table. In part A, we want to estimate v prime of 16. And what we have to work with is a table of velocity values. So for this question, we're going to use an average rate of change to approximate the instantaneous rate of change. My first move is to find where that 16 falls. So I look at my table up here, and I can see that the 16 is going to be right in between the 12 and the 20. So this is the portion of the table that I'm going to do my average rate of change. So we do 240 minus 200 over 20 minus 12, and that gives us the answer. Remember, you must show a difference, subtractions, and a quotient, and that the simplifying is optional. If you simplify, make sure you do it good, because if you do it wrong, then you will lose your point that you've gained. So I would advise just stopping at this point right here. Part B actually has 2 questions in it. The first part wants us to explain the meaning of this integral. And whenever you explain the meaning of an integral, there's 3 parts to it. First is what it is, and we should recognize this as a total distance traveled integral because we're integrating the absolute value of velocity. We also need to say units. We are measuring that total distance in meters for this question. And the final part is to say what the limits mean in the context of the problem. So 0 to 40 is just her time interval in minutes. Putting all that together gives us this explanation. The important part for you to say is a total distance in meters and that time interval from 0 to 40 minutes. You have to have all 3 components to earn this 1 point. There's a second part of part B that wants us to approximate that integral using a right Riemann sum. A right Riemann sum is simply finding the area of rectangles. To find the base of the rectangle, I look at each subinterval. So from 0 to 12 is my first rectangle. So it's 12 units wide. And the number on the right, the height on the right, tells me how tall it is. So it's a 12 by 200. The next one from 12 to 20 is 8. The number on the right is the 240, so 8 times 240. Be careful on this next one. My interval from 20 to 24 is 4 units wide. But since this is the absolute value of velocity, that negative 220 needs to be absolute valued before I pull it into my right Riemann sum. So it's 4 times a positive 220. And then 16 times the 150. And that is my right Riemann sum. There's no requirement that you simplify this. You earn a point for that right Riemann sum and a point for the answer. If you don't simplify it, then you simply just earn 2 points for the answer that I have boxed. In part C, we have Bob riding his bike, and Bob's velocity is given by this function b of t. And we're asked to find Bob's acceleration. And what we know is that acceleration is the derivative of velocity. And a simple power rule will give me that derivative, which is worth 1 point. I'm then asked to find that acceleration at t equals 5. So then I just take my 5 and I plug it into my b prime function. There is no requirement to simplify this, so simply just changing the t's into 5s is going to earn this answer point. If you choose to simplify and get it down to the final answer of 15, you may do that, but you don't have to. In part D, I'm asked for Bob's average velocity. Our interpretation of that is an average value of velocity. So we want to take an average value approach to this. Integral over interval. My interval is from 0 to 10, so that part is going to say 1 divided by 10 minus 0 times the integral, and I use that same interval as my limit, 0 to 10. If I'm doing average value of velocity, what belongs in the integrand is Bob's velocity, so I write that there. You could write b of t here if you wanted to, but knowing that I have to do this antiderivative by hand, it helps me to have that function written here, but it's okay if you have b of t written there. That's going to earn you this point right here to have that correct average value set up. My next move is to find that antiderivative. It's a fairly simple one. Just add 1 to the power, divide by the new power. My limits move to the end. A correct antiderivative, so just this portion right here, is going to earn the second point in part D. And now my last move is to plug in those limits. And I just need to plug them in without simplifying. So I'm going to leave it at the boxed answer right here. and that's going to earn my final point. And just as before, if you wanted to simplify this and get it all the way down to a single number of 350, you can, but if you do that calculation incorrectly, it's going to make you lose that last point.